Let's now talk about the regression line. Okay, the regression line is the line of best fit. We could think of it as the line of best fit. So what do I mean by this? So let's say we have some data, and I don't know, we'll say maybe the data looks like this. Okay, and so there's going to be some line that goes through this data that's going to actually fit the data the best. It's going to have the least amount of error. And the way that they actually calculate the error is that they would find this vertical distance for any of these points, okay, the distance in these two y values, and then they would square that distance, okay, because some of them will be positive, some of them will be negative, and so you would have all these squares, and it looks like this one would have a very little square, okay, so there would be all these squares or whatever, and the regression line, the line of best fit, would be the one that minimizes the area of all those squares. And so we're not going to worry about any of that, how to calculate the error, how to make the error the least. Okay? What we want to do here is that we are going to want to find the A and the B for the line that actually is going to fit the data the best and end up with the least amount of error there. And we're not going to worry about the error. We're just going to learn some formulas for A and B. Okay. So one thing that we first need to note is only use the regression line if there is enough evidence to conclude a correlation. Okay, so we learned the hypothesis test, if you remember, and it used this table here. These were like critical R values, and our correlation had to have a strong enough, the R value for our sample had to be strong enough in order to conclude a correlation in the entire population. You're going to want to be able to conclude a correlation. Otherwise, your regression line would not necessarily give you accurate results. If the points really don't have a correlation in the entire population, why use a regression line? Okay, that's important. So you only use the regression line if there's enough evidence to conclude a correlation. And then the formulas here, I'm going to teach you some. This is different than the ones in the book. This is a lot easier. But the formula for B here is just SSXY divided by SSX. So we've already learned how to calculate these SS's, and in fact, to calculate R, you already have calculated those SS's. So this is a really easy way of calculating B, and it's much simpler than the formula that's given in your book. So there's another one for A here. A is just Y bar minus B times X bar. Okay? And this is where, I guess I'll have to put this up here, X bar is just equal to the sum of X over N, and Y bar is just equal to the sum of Y over N. So these are really just the average of the X and the Y bar, the X and the Y values. Just like X bar is the sample mean, well, this is the mean of the X values, the mean of the Y values. Once you find B, you can plug it in to these, and then you can get the A and the B. Very easy formulas to use. So this really isn't really isn't too bad here. So what I'm going to do is I want to use this example that we did earlier, and we already got a bunch of the information that we need here. So this was the churches and violent crimes, or not, churches and crimes. So you had a sample of 7, I think 7, 1, 2, 3, 4, 5, 6, 7 small towns, and we record the number of churches and the number of average number of crimes per week, and we saw that there was a very strong correlation between the two. And in fact, if we use an alpha of even 0.01, I think, so the degree of freedom would be 5. So a degree of freedom of 5 gives me, even at the 0.01 significance level, as long as it's greater than 0.875, we'd have enough evidence to conclude a correlation. And so in this case, we do have enough evidence to conclude a correlation. So in order to calculate B, or A and B, for the regression line, so it makes sense to do a regression line, in order to calculate it, we need some of this information. And I'm going to get just the information that we need. So let's think about it. We need SSXY and SSX. We need those for sure. So let's write that down. SSX is equal to, and we've calculated this, 87.7143. So 87.7143. Okay. And then I need SSXY. And that ends up being 72. And then notice I'm going to need, that'll give me my B. Those two will give me my B. And then what I'm going to need here is I'm going to need the Y bar and X bar. So I need the sum of X and sum of Y as well. So sum of X, sum of Y. So sum of X is 45, sum of Y is 35. And then you're going to need in this case, is 7. So this is the information you're going to need to calculate the regression line for this example. Oh, what was I going to say? Oh, it's very important that when you do this, that you actually use the SS's. Don't use, I've seen a lot of people use the sum of XY and the sum of X squared. For their SSX and SSXY. You got to make sure you use these when calculating B, okay? And then you're going to need, so those, you need those two. You don't need SSY, but you do need these two sums. So now what I'm going to do is I'm going to break this down into 4 steps. Step 1 is calculate the B, okay? So B is going to be equal to 72 over 87.7143, and that's going to give me my B. So 72 divided by 87.7143, and I get 0.821. Okay, what I'm going to do is I'm rounding that to 3 decimal places there. Okay, just like the R. And now, step 2, before I can calculate the A, I need to get the X bar and Y bar. So step 2 would be calculate X bar and Y bar. Okay, so X bar is just 45 divided by 7. So 45 divided by 7 gives me 6.4. And I'm just going to round to 1 decimal place, I guess, like we normally round the mean. y bar is just 35 over 7, and that's just going to be 5. So that's my x bar and my y bar there. So step 3 is going to be to calculate a. Okay, so a here is the y bar minus b times x bar. So y bar is 5 minus the b is 0.821 times the x bar is 6.4. And this is going to give me my a. 5 minus 0.821 times 6.4. And I get negative 0.2544. I'm just going to round to 3 decimal places again. Negative 0.254. So step 4 is to write out the regression line. Okay, and so you want to finish. Remember, what you want is the equation of a line. Okay, you want an a plus bx. You don't want numbers necessarily. So you've gotten the b, you've gotten the a, and now you need to put them together in here to get the regression line. So I get negative 0.254 plus 0.821 times x. And this is my final answer. Okay, this is the regression line. So we use these two formulas to calculate the regression line. These 4 steps, I think, help carry you through the process so that you actually end up with the equation of a line. Okay, so I encourage you to use those 4 steps. Now there's one other thing in this section, and that is when you're given the regression line, or when you have a regression line, you can make a prediction. Okay, so let me give you an example here. So the one that we did was these churches and violent crime, or churches and crime. I keep saying violent crimes. They're just churches and crimes. Where is that? Oh, here it is. Okay, here's the regression line. And let me write it out here. Negative 0.254 plus 0.821 times x. You can see that this actually makes, the line that I did here actually is pretty good. You know, it's probably not the exact regression line, but you can see that the slope is a little bit below 0. I'm sorry, the y-intercept is a little bit below 0. And this slope here, for every one you go up just a fraction of 1. So this actually, the line that I did and this actually are pretty comparable. Okay? So now, let's say I want to make a prediction. Let's say I want to predict how many, if a town has 5 churches, how many crimes are they going to commit per week? Okay? So what I'm doing is I'm saying, 5 churches, how many crimes is that going to be? So for 5 churches, what would the point be on the regression line? And that would be a prediction. That won't necessarily be what you would actually see because the points are scattered along the line, but it'll be close. If these really lie along a line, then when I plug in 5 into the equation for a line, I'm going to get a number that goes along with these points. So the regression line is being used to make predictions. Okay? So it would be like this. Predict y when x equals 5 churches. And y would be the number of crimes, right? Average number of crimes per week. So I would do negative 0.254 plus 0.821 times 5. So what I'm doing is I'm plugging the 5 in for x, and then I'm calculating what my y would be. So it's just a matter of plugging it in and then calculating your y. And then that would give you kind of an estimate, the approximate number of churches for a town. I'm sorry, the approximate number of crimes for a town that has 5 churches. Okay? So, negative 0.254 plus 0.821 times 5. So I'm just plugging that in, and it looks like this is approximately, or actually equal to 3.851. And if you look at the graph here, that actually makes sense, I think. 3.81, that actually fits, doesn't it? Okay? So, the problems in this section then is asking you to determine the regression line and then make a prediction. Okay? And it'll tell you what the x is, and then you want to give what the y is going to be. Now, on the homework, it's going to generate data sets at random, and you may or may not have enough evidence to conclude a correlation. So the first thing it wants you to do is decide whether or not there's enough evidence to conclude a correlation. And so you got to test and see. If there's not enough evidence to conclude a correlation, you're done. Okay? But if there is enough evidence to conclude a correlation, you determine the regression line and then predict what y is going to be given a certain x value. Now, if you happen to have a homework assignment where each one ends up being one where there's not enough evidence to conclude a correlation, that can actually happen, which is unfortunate. It doesn't happen very often. If that's the case, you're going to want to try at least a few of these to make sure you can do it. And I'm going to put one up on Canvas along with solutions so that you can get practice doing this. I'll put one up there. There's one as a daily activity. We're going to do a couple in the next couple videos. So you'll get a little bit of practice with this. But then on the homework you'll get some more, unless you're one who is lucky enough, or maybe perhaps unlucky enough, to have data sets where there's not enough evidence to conclude a correlation. Okay, so if that's you, make sure you're getting some practice. You can also go to the ebook and go to the problems at the end of section 10.2, and you can try some of those. Okay, and do some where you actually have to determine the regression line. And then the answers for those are in the back of the book. Okay, so that is how to determine the regression line. In the next couple videos, we will do some more examples of that. And I'll give you a chance to work on it before I do it myself and we discuss it. So.